Okay, so today are equations of linear functions. You have done linear functions in Algebra 1 and in geometry, so a lot of this should be very familiar to you. Today we're going to talk about 3 different forms of linear equations. You have standard form. That's actually probably the form you're least familiar with. So we're going to do that today, and then our favorite slope-intercept form, and then we're also going to review that point-slope form, okay? And with those formulas as well, we're going to talk about the slope formula. So the first thing we're going to do is put equations in standard form. So let's read about this. It says any linear equation can be written in standard form, which is ax plus by equals c. Okay, so that's what the standard form is going to look like. You're going to have your x value and then your y value, and it's going to be equal to the constant value c. A is the coefficient of x, b is the coefficient of y, and then c is the constant that's going to be on the right side. Now, there are some different restrictions here. Now, the first restriction says where a is greater than or equal to 0. What does that tell me about a? It has to be positive. Okay, so this says interpret the restrictions on the values. So a is greater than or equal to 0. That means that it has to be a positive value. Okay, so we're just going to write some notes underneath. It's where a is positive. Now, if a wasn't positive, do you guys know what you could do to an equation to make the a value positive? Yep, multiply or divide by -1. Good. Okay, now it says a and b are both not 0. That's just because if a and b were both 0, you wouldn't have an x or a y. Okay, you wouldn't have an equation, a linear equation there. Okay, so that's not something that we'll have to worry about. And then it says a, b, and c are integers with the greatest common factor of 1. Now, I know sometimes we just kind of glaze over that information. Today we're going to dive a little bit deeper into it. So what does it mean that they have to be integers? What's an integer? A what? What? Be more specific. There are lots of numbers. A whole number that is? Or 0. So positive and negative whole numbers and 0. Okay, so what doesn't that include? Fractions, decimals, okay? So if you have those, again, we're going to use a multiplying technique to undo them, okay? Now the last thing is that the greatest common factor is 1. Okay, so if they're saying that the GCF has to be 1, okay, that means the numbers are not divisible by any number besides 1, and the number itself will be divisible by itself. But there's no other number that would go into A, B, and C besides 1.
That's the prime number.
It's not the prime number because this is the greatest common factor. So the numbers aren't going to be prime. If a prime number is a number that's greater than 1, where the only things it's divisible by are 1 in itself. The greatest common factor would be the biggest number that goes into each one. Okay, for example, like 4 and 16. What's the biggest number that goes into both? 4. So if you have those values, then you have to take it out. But because there's 3 values, sometimes they'll be divisible by 2 and not the third one. Okay, so we're also going to write underneath here A, B, and C. They have to be integers. So those are the 2 big ones that we're going to focus on. A is positive, A, B, and C are integers. Okay, so for the first example, we're going to write the equation in standard form and then identify the A, B, and C. Okay, so we have to write the equation in standard form and then identify our A, B, and C values. So the first thing I recommend that you do in this process is to write the equation in standard form, which is the ax plus by equals c. Okay, so we'll take care of that first. So we have the x on the right side, we need the y over. You can't just move this over. How do you cross the equal sign? Subtract it. Okay, sometimes people forget and they just try to move it. You can't do that. You have to use your properties of equality. Okay. Alright, now once you have that, you can do the next two steps together, and that's making sure that a is greater than or equal to 0, and making sure that you have integers. You can do those at one time. Okay, so in this case, is a positive? No. So just like we talked about, we would want to multiply everything by -1. Are these integers? Are they whole numbers?
No.
Positive or negative? No. So these are decimals. What place are all these decimals?
Tens.
The tens. So what can I multiply by? Remember, if you multiply by something, it'll move the decimal.
10.
If you multiply by 10, it'll move it one place. If you multiply by 100, it'll move it two places. Multiply by 1,000, 3 places. So because all of these are the tens place, all you have to do is multiply each one by 10. So like I'm saying, we can do these together. If you times by -1 and times by 10, really we could just multiply both sides by what? -10. So write what you're multiplying by, and then we're just going to distribute. So -10 times -0.02x is going to be what? If I move the decimal place? 2x. Good. Okay, and then here, I would get a negative times a negative is a positive, so this is going to be what number? 21. And then you'll have 19. Okay, so your A value is 2, it's positive. Your B value is 21, your C value is 19. So for the GCF1, is there any number that goes into all three of them? No. So like the 2 is prime, the 19 is prime, but 21 is not prime. That's okay.
That's just the answer.
Yep. So you have it in standard form in your A, B, and C.
And if there was a number I could go to all of them, you just write DCF.
If there was a number that could go into all of them, you would divide them all by that number. Yep, so if like 3 could go into all of them, you divide them all by 3. Yep, good question. Alright, for B, I want you to do step 1. So I want you to put this in standard form and write it down. Okay, so the x has to go first, so -3/7 x should be in front. This is a positive 2/5 y. And then if you move over the 4/9, did you remember to subtract it and put the negative there?
Yes.
F. Alright, so now we are going to multiply by something, okay, that's going to get rid of the fractions, okay? Now, if we just had this fraction, what would I multiply by? 7. What if I just had these two? 35, because that's 7 times 5, okay? So now that I have that, we're just going to do 7 times 5 times 9. So we're going to multiply by the LCD, the least common denominator. Okay, so to get the LCD, we're just going to multiply 7 times 5 times 9. When you multiply, you get 315. Okay? Now we're going to look at the A value. So is the A value positive? Okay, so if we need to make that, then we're going to multiply by -1. So on each side, we're going to multiply by -315. Okay, so like I said, you could do that in 2 steps or 1. I think that we can handle doing it in 1 step. So I'm going to multiply each side by negative 315. Please go ahead and do that in your calculator, and if you're unsure, I'm going to show you how to do the first one if you're unsure, so don't worry. Okay, so when you're multiplying a fraction, you always multiply it by the numerator and then divide by the denominator. Now, I don't like to deal with negatives, and we know that a negative times a negative is a positive, so I'm just going to deal with the positive, okay? So I'm going to do 315 times 3 divided by 7. Okay? Oh, sorry. I had something extra. Okay, and then you get 135, that's your coefficient of x. Okay, so now I want you to find the coefficients for y. I want you to find the value for c. Okay, and then label your a, b, and c. Once you've done that, once you've found your a, b, and c, I want you to go on to example 2 because that is something that you have done before in algebra. Okay, so do this. Do the calculation over there? Is that your calculator? Make sure you're paying attention to your signs. So this one should be a negative. What's that? Yep, that's the only restriction we had up here, is that a had to be positive. Alright, and then you can check yours with mine, make sure you did the rest of it correctly. So let's see if we can simplify with the GCF. So, like, 126 and 140, I know they're both even, those are divisible by 2, but 135 is not. I know 135 and 140 are divisible by 5, because they end in 5 and 0, but this one isn't. Do you guys know how to check quickly if they are divisible by 3? You can add the digits. Okay, so like 1 plus 3 is 4, 4 plus 5 is 9. So does 3 go into 9?
Yes.
Yep, so it goes into here. 1 plus 2 is 3, 3 plus 6 is 9, 3 goes into here. 1 plus 4 is 5, 5 plus 0 is 5. So 3 doesn't go into 5, so it won't go in there. So nope, there's no numbers that are going to go into all of them. Okay? And that will happen because you don't have any similar ones here. Alright, so I asked you to start this one where you're writing in slope-intercept form. Okay, slope-intercept form should be second nature to you at this point. You should know right away that that's y equals mx plus b. Okay, where m is your slope, b is your y-intercept. Okay, and then we have to identify the slope and the y-intercept. So we'll do that. So if I am getting it in this form, really I'm just solving this equation for what variable? Y. I'm just getting y by itself. So the first thing you should do is move over the 10x. Did some of you divide by the 2 first? Okay. And this one, you could divide by 2. Just make sure you divide everything by 2. So when you divide by 2, you have to divide the negative 10 by 2, the 16 by 2. Okay, so y equals negative 5x plus 8, and then you just have to identify your slope, and you can use m and b for that, okay? That's it. Okay, and then for this one, again, you're trying to get y by itself. When you're getting y by itself, leave it alone. You're going to move anything that's not y over. Okay, we want y on the left side, everything else is on the right side. Okay, and don't be intimidated by this fraction. All we did is moved it to the other side, so it just stays the same right now. Another thing you'll want to double check is if it has a negative in front, make sure you drop that down. Okay, and then how can I get rid of this negative 1/3? Multiply by the reciprocal. What's the reciprocal? Negative 3. So 3 times a third is just 1, right? Negative times a negative is a positive. On this side, you'll distribute. So when you multiply a whole number by a fraction, you multiply by the numerator, denominator, or both? Numerator, because didn't we just do that? Up here, right? We multiply by the numerator, and we divide it to simplify it. For this one, we're just going to multiply it. Negative 3 times negative 4 is 12. Can I simplify 12 over 5? No. Okay, we knew that these would simplify because we multiplied by the LCD. We did that to get rid of the fractions. Okay, sometimes you can't get rid of them. Okay, so y equals 12/5 x minus 9, where your slope is the 12/5, and your y-intercept is negative 9. Make sure you put the negative with it. Alright, so our next example is about kayaking, and they give you the linear equation y minus 12x equals 25. That is describing the cost to rent a kayak at the East Bay Paddle Company. It says where x is the number of hours a person uses the kayak, and y is the total cost of the rental. Okay, do you guys have any experience like renting? Done on kayaking or paddleboarding before? Okay. I was gonna say, I know they have those, the scooters sometimes, and I wasn't sure if you guys did some of the renting with that. Okay, so you're gonna write the equation in slope-intercept form, and then we're gonna interpret the parameters in the context, which means you're gonna have to explain using your units. And that's where I would go back. If I know I have to interpret, then I need to pay special attention to what the x represents. So that's the number of hours a person uses the kayak. Y is the total cost. And then I'm ready to do my 2 steps. So the first step is to write the equation in slope-intercept form. Well, they gave us the equation, the y minus 12x equals 25. So putting that in slope-intercept form is going to be pretty simple. What's the only step we have to do? Right. Okay, so y equals 12x plus 25. Okay, step 2 is going to be to interpret the parameters. So in your equation, you have a y-intercept and you have a slope. Basically what we need to do is think about what those represent in the equation. Remember that a y-intercept occurs when your x value is what? 0. Do you guys remember what that meant? We talked about that in chapter 1. The x-intercept is what?
The x-intercept is...
sorry, the y. I know I said that. The y-intercept.
Y-intercept is...
The y-intercept is the what?
Is 1.5.
Yes, but what does it mean in context?
Oh,
yes.
it means like the rental cost.
It is going to be part of the cost. What I'm looking for a certain word. Ashley, you got it? Yeah, good. Okay. This is your initial value. Okay, and then it is the 25. So we're going to write that down too. Now, in the case of the kayak, right? I want you to start thinking about what that means, okay? What that $25 means. So if you go to rent a kayak, that $25, what could we call that? Well, what does it mean? If you go to rent a kayak, no matter what, you're getting charged the 25, right? Yeah. Yes, your rental fee, your base fee. Okay? That's not based on any hours or anything. That's where the slope comes in. So when you're thinking of a line and you're using the slope, remember how we would do like 12 over 1? That means it's increasing by 12 each time. So it's the increasing value per unit. In this case, our slope is 12, but what does that mean? The cost per hour, good. Okay, so for every hour, you're going to be charged $12. Okay, and then when you're writing this up, just make sure you include the units, so the hours and the price, which we did here. So the interpretation is just going to be a sentence. The base fee for renting a kayak is $25 plus an additional rental fee of $12 per hour. All right, and that would be your answer for step 2. All right, so we're going to do another story problem where we're going to think about what our X and Y values are. So at 1 p.m., a meteorologist records a total rainfall of 11.5 millimeters for the day. After continued rain, the total rainfall at 5 p.m. is 16.7 millimeters. So it says define variables to represent that situation. Okay, before we do that, let's think about what this situation is. Okay, what are we dealing with here? Okay, so the amount of rainfall, and what other unit are we using? The time. Okay, so we want to estimate, we want to be able to estimate the amount of rainfall based on time. Okay, now when we're explaining this, again, we're going to have to make sure that we use our units. So every time you're defining variables to represent, you can always start with let X represent A, and then tailor that to the situation. Let Y represent, tailor that to the situation. Okay, which one is my input here? The X or your Y? Okay, so this is the input. So what is this based on? Is the rainfall based on the time, or is the time based on the rainfall?
Rainfall based on the time.
Okay, so if it's based on the time, that means our X value has to be what? The time. So let's use our units. In this case, the unit of time is what? Yep, the number of hours. Help, the British are coming. That will you shut the door for me? Alright, and then let Y represent the total amount of rainfall, and what's that measured in? Yeah, the total amount of rain in millimeters. Okay, so find the slope of the y-intercept, then write an equation. Okay, so the simpler one to start with is going to be the y-intercept. All you need is the slope and the y-intercept to write an equation. So let's think about where this starts, right? So it starts at 1 p.m. Okay, so that initial value is 11.5. That's going to be your y-intercept. Wherever you're starting at, that is your y-intercept. Okay, now slope has been described in many different ways, right? Rise over run. We have some equations. Okay, one way that you can describe the slope is the change in y over the change in x. Have you guys seen this triangle symbol before to represent the change? It sometimes pops up in science. It's the delta symbol. Okay, so the change in y over the change in x. We can also apply this to a set of points. The y2 minus y1 over x2 minus x1. And you're definitely familiar with this one. Okay, so if we're doing the change in y, let's create a set of points here. Okay, we said that x is the number of hours that you have that rainfall. Okay, so in that case, you can use the 1 p.m. and the 12.5. Or sorry, 11.5. Okay, so at 1 p.m. it was the 11.5. And then at 5 p.m. it's the 16.7. Okay, so you can use those points to find out what your slope is. And it really doesn't matter which one you use as your x1, y1. I'll just always use my first one as the x1, y1. The second one is my x2, y2. And then we're just going to plug these in. So 16.7 minus 11.5 over 5 minus 1. Okay, so I want you guys to calculate the slope. Finding your slope is always the first one. You have negative 2 minus 6, negative 5 minus a negative 3. So when you have a negative over a negative, what happens? Positive. So your slope is 4, and then it doesn't matter what point you use. So you can do y minus 6 equals 4 times x plus 3, or you can have y plus 2 equals 4 times x plus 5. So whichever point you use is fine.
I have to write those one down.
No, I just said that.
I was just doing my math.
Okay. Yeah. You only have to pick one. I usually just use the first one because I've already labeled it my x1, y1. Okay, but I just want to let you know you do have your choice. Alright, so our last example about subs. Popular Sandwich Shop sold 174 subs by 8 p.m. and then by 10 p.m. it had sold 290 sandwiches. Okay, so 174 by 8 p.m. I think that's going to be important, so I'm going to box that in. And then 10 p.m. the 290. Write an equation in points sold form that represents the number of sandwiches the shop sold after it opened at 5 p.m. Okay, so the 5 p.m. is important because this is going to be the start, right? At 5 p.m. So let's think about what our x represents and what our y represents, and then we can turn these into points. Okay, so the x, what's that going to represent? Well, we have 2 units here, right? We have the subs and we have the time. Okay, so the x is going to be the time, okay, and this is going to be measured in hours, okay, from the starting time. So we'll measure it from the 5 p.m. Okay, and then the y is going to be the number of subs. We'll just put subs. All right, so then let's turn these into points. So 174 subs by 8 p.m. What would the time be for that? 3 hours, because it's since the start, right? So since 5 p.m., that would be in 3 hours they made 174 subs. And then by 10 p.m., how many hours did they have to make the 290 subs? 5. Okay, so x is the time in hours from the start when they open. Y is going to be the number of subs. Okay, so I want you to go ahead and calculate the slope from there. And then you're going to write the equation in point slope form, okay? Alright, let's see how we did. So when you're calculating the slope, 290 minus 174 over 5 minus 3 is going to give you 116 divided by 2, so you should get 58. So remember, your slope is representing how many subs they make in an hour. So 58 subs per hour. And then you are writing the equation, so whether you chose the first point or the second point, you just need one of those equations, okay? You just need one. And for the people watching the video, I'm sorry because I paused it and then I don't know how much I missed, so hopefully you guys got everything.